Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is talk about GraphQL. Okay, and the purpose of this video is just to help give you an understanding of the GraphQL landscape, like why does it matter, what is it, what are the tools, and all of these things. Okay, so let's do that. Okay, so first off, let's make a new slide. So I'm going to just do this. We're going to construct the slides together. What is GraphQL? Okay, GraphQL is sort of a new approach to creating APIs. A newer approach to creating APIs. It was created by Facebook. Okay, it was Facebook who created GraphQL, kind of like it created React by its own, from its own needs. And the beauty of GraphQL, what it does, it allows you to kind of create, instead of like using a graph database, which you can use, a graph database which organizes all your data into nodes that are interconnected in different ways. What you do is you take all your different inputs, all your different data, right? Which could be coming from a database, which could be coming from a JSON file, which could be coming from, you know, a CSV file, also all your different, or from a third-party API, all your different data sources. And what you do is you create this GraphQL layer, which essentially what you're doing is you're defining a graph, but the graph isn't any particular data source. It's not a particular database, but it's a set of definitions that are laid on top of all your data sources. This is essentially what you're doing when you create a REST API, but there's some downsides to a REST API. So at the end of the day, a GraphQL is an alternative to REST APIs. And we'll talk about what REST APIs are so you can see the difference. Okay, but that's what GraphQL does. It creates this graph layer over all your data sources from the back end, which then gives a lot of new flexibility to the front end. Okay, but first let's just kind of like explain like what REST APIs are so you can see like what the big differences are. So let me head over here, create a new slide. Okay, what is a REST API? Now, the word REST, well, this acronym stands for Representational State Transfer. Okay, so the idea is you're transferring state or data from your back end to your front end. So basic REST is just a standard way of interfacing the sharing of that data. And the way we do this is through several endpoints. Okay, through several endpoints. And what's an endpoint? An endpoint is a combination of a method. Okay, so we could be talking about like get or post, and then a end of the URL. So it'd be something like a get or a post to /dogs. And depending on which endpoint, each endpoint returns a set amount of data. Okay, so if I sat there and made like a get request to /dogs, I'd probably get a list of all the dogs, but I would get all the data on all the dogs, which may not be what I need. I may need all the dogs, but maybe I only need their name. I need all the dogs, but I only need their ages. And the reason why this matters is if I get all the information on all the dogs, I pull that data from an API and store it in memory in my front-end application. Well, I've just stored all this data I don't need in the front-end application. That's eating up memory. And again, for very large applications and very large data sets, that could really hurt sort of the running of the application because you're holding all this data in memory. You could create custom endpoints, but then you're just creating a lot more endpoints. Okay, and then it gets kind of hard to maintain. So that's one of the things with like REST. Okay, so again, REST is all URL based. So different data that you want gets requested from different URLs using different methods. Okay, but again, you can't really control the data you receive. There are ways to do that. You can, you know, tailor the different endpoints, but that requires more documentation. It's not really done in any. Every API is going to be different. There's not really a standard on how to do that. There's some conventions, but what's going to happen is that like the more flexible you make your REST API, the more documentation you're going to need, the harder it is going to be for people to use because it's not really following that sort of cookie cutter, like let's say your RESTful routes per se. But keeping it sort of like in the standard sort of RESTful routes pattern, you might be giving way more information than the user needs. And again, now they're having this issue of all this excess information that they have to kind of deal with. So how does GraphQL solve this? Okay, GraphQL versus REST APIs. Now the way GraphQL APIs work is that it's always a post request to one URL. Okay, so there's always like one URL. It might be like /GraphQL or something. But what happens is that you'll have a GraphQL server that's listening on that URL. And that URL receives a query string. A query string, which is either making a query, meaning you're looking to receive data, or it's making a mutation, which means you're trying to either add new data, update the existing data, or delete data. Okay, you're transforming data, you're mutating it. So you're either querying or you're mutating, but you're always sending the request to the same URL. So you don't have to memorize a whole bunch of different URLs. Okay, instead what you're doing is you're sending over a string. A string specifies which query or mutation you want. Every query mutation may return data. Okay, and the cool thing about it is you can specify what data you want. So if I were to query all the dogs, I could specify I only want to get the names back. Okay, and it will only give me the names back. So I can detail which data I want back. So I don't have to memorize a bunch of endpoints. There's always just one URL, so it's a standard sort of interface. Okay, and two, I can detail which data I want to get back, which means I can make sure that my front end isn't eating up as much memory when it gets large data sets. It can only grab the pieces it needs. There's a lot less, front end data transformation or back end data transformation. All that matters is that you know what data is available. And this is done through typing. So basically what you have to do is in GraphQL, which we'll get into in a moment, when you create a GraphQL API, you have to define all your data types. Okay? And you have to sit there and say, okay, well, a dog is something that has a name, an age, and whatnot. These things are required, so forth, so forth, and so forth. But the benefit of that is, again, you have that flexibility. On top of that, you have, great tooling. Okay? We'll talk about things like GraphQL, what's called like a tool called GraphQL, GraphQL Playground. These are tools that allow you to enter like queries and mutations and test them out. And the great thing is it's self-documenting. Because of the way it's written, it actually develops its own documentation, because it's another problem with a lot of APIs that, when you're doing a REST API, it doesn't automatically document itself unless you're using a tool like Swagger, which Swagger is pretty cool. But if you're not using Swagger, then you have to create your own documentation, and that documentation you may not maintain, and that makes it hard for developers to use your API. So the great thing about GraphQL, it is self-documenting. It actually creates its own documentation. Self-documenting. Okay, cool. So that's, it creates its own documentation. Cool. And again, it can be done in any language. You can create a GraphQL server. You can use any language. Every language has frameworks and libraries for creating GraphQL APIs. So now we know sort of why you would want a GraphQL API versus a REST API. Okay, but let's kind of get into sort of like these terms. Okay, so new slide. So whenever you're creating a new GraphQL API, there's generally a few different parts. Okay, there's your type defs, aka type definitions. So basically what's going to happen is you have to define everything. You have to define what type of data. And this can be a little tedious because generally you have to do this also for your database. So if you ever use like Mongo with Mongoose and have to define like your schemas and models, if you ever use like a Postgres database or any kind of SQL database and have to define your models and schemas ahead of time, you know what I'm talking about. You have to sit there and say, okay, these are the fields in the thing. But even if you're using and you've done that for your database, you have to do it again for your GraphQL API. Okay? So you have to define types, queries, and mutations. These are the things that need to be defined. Okay? So you might have something that looks like this. It might be like, type dog. All this be lowercase. and then you would put like curly brackets around it. And we would say that type dog has a name field, which is a string. Okay, and again, that's going to be a lowercase name field. And then if that's required, I might put like an exclamation point on it, so that makes it like required. Although I always forget, do I put the exclamation point there, or do I put the exclamation point? I think it's there. Okay, and that would make it like required. And then there's, you would just go forth and specify all these different like data types. So I'd say, okay, there's also age, which, autocorrect, age, which is an int, and that's also required. Okay, and you'd have to sit there and define all these types. So you have to define what a dog is, and on top of it, you have to define all your what's called resolvers. Okay, resolvers, the functions that run when a query or mutation is run. So again, a query is something where you ask for data, so it's going to return data, and the mutation is when that's going to change data. So you would have to define these in your type def. So in your type defs, you would actually have like something like, let's see here, let me go bring up VS Code. Okay, and what I'm going to do is make it like a new folder here. So open folder, where am I at? Yeah, let's create a new folder. We'll call this GraphQL. Oh, I already have a folder called GraphQL, so I might have already covered this. So let me just head over to that folder. GraphQL, there you are. Yep, yeah, because I recently did a video on this. So just to kind of give you an example, resolvers, type def. So these are my type definitions. So notice, let me just get all this stuff out of the way. So basically what you do is you have to create this big string that defines all your types. So you see here I'm defining a type called book, which has a title and a string. But you also have to do types that are called inputs for like, that are like, basically think of them as defining like the arguments to a function. So there's an input, and it's called new book, which takes in a title and an author. And then I have to define my queries and mutations. So you see here I'm defining that there's a query called books. And whenever you use the books query, it returns an array of books. Okay, so array of book types. And it knows what a book is because I defined what a book is over here. Okay, and basically once I've defined the types, so I've defined the types, the queries, the mutations, at a high level, I have to then go create a function for each resolver. So that's why these are, a function for each query mutation. These are referred to as my resolvers. Okay, so you can see here, with the query, I have a books resolver that resolve that books query. And so basically anytime I call the books query, it's going to call this function, which just literally returns the array of books. And then in this case, I have a add book mutation that what it's going to do is that it's going to push something into the books array and then return me all the books. Okay, pretty neat. Okay, so that's essentially like what we mean by you have to define your types and define your resolvers. And again, that's just there in JavaScript using Apollo server, but again, there's different frameworks, but the pattern's always the same. You define your types, you define your resolvers, you define your, and then you have an API. Okay, and the cool thing about it is that once you have the API, so let me actually open this up in terminal. So let's just do, let me see, what do I got for, do I got scripts? Yes, I do. npm run dev. Why don't you want to play? Oh, I got a CD into the folder. CD GraphQL backend. Good. And then let's do npm run dev. Okay. And you can see here that I'm running on 127.04,000, so localhost 4000. And see, this is the kind of tooling you get when you're using GraphQL. So again, from the backend perspective, this is really nice. Also, the front end developers can use this to interact and understand. But you saw, like, I wrote that code, and if I click over here on docs, see, I can see documentation. It self-documents because it reads those types and knows how to turn that into documentation. So it knows that my API has these queries and these mutations. And I, as like a front-end developer, I would be able to look and click on like the books queries and say, oh, okay, there's a query called books. If I call books, it's going to return me an array of books, and books have these two properties. Good. So let me try that out. Okay, so then I can just be like, Okay, I'm going to call a query. So I would just do curly brackets and say the query I'm calling is books. And basically books doesn't take any arguments, so I don't have to pass anything in there. And I can just say, okay, I only want titles. That's it. That's all I want. And see, I get all the books and just the titles. Or I can say I just want, I just want, what were the, I think it was author was the other one. I can just get author. Okay, and see, I just get the authors, or maybe I want both. Title and author. And I get both pieces of data. So the cool thing here is I can create my query string through this tool. So again, using something like this, this is a GraphQL Playground. There's also GraphQL. But I would use this tool to test and create my query string, and then that would be what gets sent over my request when I'm doing a request from the front end. So it makes it really easy to test, and again, really easy to kind of figure out what I need to do because I have this documentation. Once you kind of get used to reading it, it makes it where you're never kind of like assuming things. You know exactly what the API does because it self-documents itself, which is really cool. And again, just to show you how to use mutation, if I want to add a book, I would say mutation, and then the mutation I want to use is add book. But again, this does take an argument, so I can see here it has a parenthesis, so it takes an argument, and the argument must be of a type input new book. So then I have to define this input argument, which is going to take curly bracket, which is going to take like another object, which has to have the properties of a new book, so I can look at what a new book is. So see, he says here what a new book is, and I can click on that and see that a new book is a title and a string, or a title, an author. So I can be like title, some book, comma, author, some author. And then after I pass in the argument, I have to specify, because this thing returns an array of books, I have to specify, okay, I want the title and the author from the return value. Okay, and now let me put the docs away and I hit enter, and see I added some book. Okay, so and if I can do it again, it'll add another book and another book and another book. But you see this mutation, all I'm doing is I'm really just calling the function by this name, passing it whatever arguments are defined in my type definitions, and then specifying what properties I want from the return value. And again, I can take a look at the docs to figure out what the return value is, because I can see this returns an array of books, it's after the colon, and I can see what arguments it takes. So there's a lot less having to like guess what you need to do. I can just sit here, figure out what my query is that gets me the right information, and then just copy that over to my code. So that's pretty cool. Okay, so we've established that sort of like how the GraphQL API sort of works. Okay, although again, this can be, as APIs get more and more complicated, typing up all these type definitions and resolvers can get pretty tedious. So there are a lot of cool new tools that allow you to sort of spin up a GraphQL API without having to do all of that. Okay. Okay, so number one in that list is Hasura. Okay, with Hasura, okay, you can just head over to the Hasura website, and what they do is they can either host or you can download their software and use it. It's open source. Well, what you can do is that you actually create your GraphQL API through a very sort of visual type of way. So you would just hook up this graph, basically define your types. Basically, you would hook up, install Hasura, then you would connect it to your data sources like your databases and whatnot, and then define your data types through the GUI, and then suddenly you have a GraphQL API. Okay, and so you can see here from your database to a unified GraphQL API in just 1 minute. Okay, you just have it read your API, so you can see kind of here's like a little illustration. So you connect it to your database, it's going to pick up on the schemas of the tables, create a corresponding API, and then your app can just call that API. Okay, that's really cool. There are other tools that can do something similar. Some of the other ones that I've heard of are Prisma. There are something a little bit different, If you use something like Strapi, Strapi is more of a CMS, but it has the ability to kind of take what you've done in the CMS and turn it into a GraphQL API. Same thing pretty much with any of the headless CMSs. So if you're using Contentful or Graph CMS or Butter, they generally all have a GraphQL API option, okay? But they don't necessarily connect to your database. You're using a database on their platform. Strapi, you have to connect. You could connect to your own database. I think same thing with these three. Like you could they can be connected to your own data sources, I think they also have hosted options, kind of like Hasura does, where you can have them host your service, and they have a tailored platform for that. But that's really, really cool, okay? Because now that takes a lot of the biggest pain point out of using GraphQL APIs, which is, having to sit there and make all those type definitions and make all those resolvers and all that stuff, okay? So that's pretty cool. Now, from the front end perspective, how do I make my API calls? So from the front end, they don't have to worry about building it, they just have to worry about calling it. Okay, so they use tools like Apollo Client, which is the front end version of Apollo. The back end version of Apollo is what I was using to build that API you saw a second ago. But there's Apollo Client, there's Relay. Those are the sort of the two ones that always kind of pop up. I always hear top of mind. But let's see here. Let's go head over to npmjs.com and let's look up GraphQL Client and see what other options you have. Or you could just make a post request, which I think I did in this example code. I'll show you in a second. But there's GraphQL Request. Okay, so that's another one. But you see, there's a lot of different clients. Generate client library for GraphQL schema. Lots of different options. But I'll show you here in the front end. Okay, an example that uses This is actually a React example that's using the Apollo React client. And just to show you how it's set up, as you see here, we set up the Apollo client at the top level, Apollo provider. Again, if you've done React Route or Recoil, pretty much many of these React libraries that make API calls or manage state, they oftentimes require some sort of provider at the top level of your app. So that's typical of a React pattern. Again, this would be different in different frameworks. But every framework has their own GraphQL libraries. And then Apollo, I think, has a different version for many of the frameworks like Vue, Angular, so forth. But then you see here, what I do is I took that same query string that I developed from going to GraphQL Playground. I saved it in this GraphQL string. And then I just pass it to this hook called useQuery. And then that makes it work. And I'm going to get back this loading error data, so I can test whether the data is loading. I can test whether the data has errored. And if all is well, I can then just return the data. Okay, so makes it pretty straightforward. But again, if I didn't need the author, I could just delete the author. Now that's less data I'm coming from. So it creates these like really flexible ways. This is also very much used in things like Gatsby to help control its server-side pulling of data from all your configured sources. So it creates this nice language of way of expressing not only what data you want, but what aspects of that data you want. Probably the biggest pain point, again, is the actual development of the API, writing the type definitions, writing the resolvers. But with tools like Hasura and others, that's not as much of a pain point either. And then again, there's new technologies, and all these platforms are improving constantly to make these GraphQL APIs faster, more robust. So a GraphQL is a great thing to be aware of, like to learn all these different libraries and tools and really kind of understand that GraphQL space. So hopefully you guys found this interesting. My name is Alex Merced from alexmercedcoder.com. Again, there should be a link in the video description to a repo where I have all my code from any of my recent videos. So you should find this GraphQL folder in there if you want to examine this code. But otherwise, have a great day and enjoy. I'll see you all later.